Hi, my name is Will Henson. I am a senior electrical engineering major, and today I will be explaining the model and discussing the modeling of a brushed DC motor. First, I would like to start off in talking about why this brushed DC motor is so important to me. For my senior design project, I will be designing and building a robotic cart that will autonomously track the user and follow them around, uh, and its propulsion will be used, or will be using two 24-volt brushed DC motors. This means that it's going to be very important that I have a good understanding of how a motor works, why it works, and that we will be able to model our cart and its use of the motors once they get put under load. So now I'd like to talk to you a little bit about the parts. So a DC motor is an electrical machine that converts direct electrical current into rotational mechanical power. The advantages of a DC motor are high torque, speed controllability, and portability. Now this is very important because of the advantages of high torque as well as the portability makes these small motors very useful. Such as in my senior design project, it's going to be very important that our motors are lightweight yet high torque and very portable since it is going to be a robotic cart. Most of the common DC motors are under 5 horsepower and generally brushed motors. DC motors that do not have brushes will often have electronics in place that will control the current running through each coil. As you see here, we have a commutator, which is the area that the brushes come in contact with. They deliver current to the rotator coils, as you can see spinning here. You've also got the brushes that deliver the current to the commutator. You've got the permanent stator magnets on the exterior of the windings, and then you've got the shaft that delivers your rotational power. Now a simple DC motor always has these stationary sets of magnets in the stator and an armature with one or more windings of insulated wire wrapped around a soft iron core that concentrates the magnetic field. These windings usually have multiple turns around the core, as depicted here, and in large motors there can be several parallel current paths. The ends of the wire windings are connected to a commutator, as you can see here rotating, with the commutator allows each armature coil to be energized in turn and connects the rotating coils with the external power supply through the brushes shown here. Now moving forward, this is a block diagram of the DC motor transfer function as well as the transfer function itself. Over here, the controller takes the input, it sends inputs to the block diagram that represents the transfer function, and once the transfer function receives the input from the controller, it outputs our response needed here. Now, moving on, we have a portion of the MATLAB code used to design our root locus over here, which is the controller I decided to use for my DC motor. We will be expecting a settling time less than 2 seconds, an overshoot of less than 5%, and a steady state error less than 1%. The variables shown here are just some physical parameters that I set just to run the code. Now, moving on, we have the step response, or the open loop response of the DC motor. As you can see, it's not the best response, so using the root locus and the design stated earlier, we will get a better response. Here is the open loop response of the DC motor, designed with a gain of 16 on the compensator. Now when we move and look at the graph, you can see that it has a rise time of approximately 2 seconds and a settling time of approximately 5 seconds, which is not great, but we would like to double the compensator to reduce our steady state error. So when we change our compensator from 16 to approximately 34, we then get a response that looks much cleaner, like this, where our rise time is much less than 1/2, and our settling time is right around 2 seconds. In conclusion, a DC motor is an electromechanical device that takes electrical current and converts it to rotational mechanical energy. And remember, the advantages of a DC motor are high torque, controllability, and portability. Well, that's all I've got. Thank you for your time, and if you have any questions, feel free to contact me at this location.